All right. Whoa. Whoa. So apparently I'm supposed to holding this microphone like this. All right. All right. So basically, apparently the title of my talk was confusing, so I changed it a moment ago. But it's exactly the same talk, so no worries. This talk is about type classes, and it's an introduction. So instead of giving you guys a definition, what a type class is, I reckon I will not give you one. Instead of, I will just tell you a story. And this is a story of a blackout in 5 acts. Act first, loss and grief. This is Jimmy. Jimmy is senior Scala developer. He's this happy senior Scala developer ever since he read this book. Now he can develop whatever production business problem that you have. He has the solution for you. The problem is, that one day, this thing happened. Not only Stack Overflow didn't work, Google also didn't work. So that was scary, right? And now the modern psychology tells us there are actually five steps to deal with loss and grief. So first one is denial. This didn't happen. The second one was how that could happen. I mean, come on. The third one will be like, bargaining. Well, maybe maybe I just should actually save some questions and answers, and maybe, I don't know. There's depression. I will never be a software developer ever again. And the last would be acceptance, meaning, okay, it's Monday, it's already 2 p.m., I should really develop this software. So the story about Jim is exactly at the point number 5, when he's accepting his doom and he tries to deal with this. So that's Jimmy, confused and worried. Act 2, the mess. So Jimmy is supposed to develop this application, which is basically an auction system like eBay or whatever. The only difference is that since it's 2016, the name has to end with "ify" and then "b" and then the "may-I-o." But the other thing is just basically an auction. Now, disclaimer, I've never actually worked for any companies that are doing auction-based systems, so I don't know what's the domain. I just think of one. So if anyone is here for working for eBay or whatever, then just sorry. But I figured the domain might look like this. So we have an order. There are like 3 types of orders. Or there might be a general order, which takes a list of products. Might be a complex order, which basically combines 2 or more orders. And might be a canceled one, which means there used to be an order, but doesn't exist anymore. There's also a product. And product might be basic, with an ID and a price. Might be discounted, which basically wraps another product with a discount. And might be out of stock. So it used to be a product, but doesn't exist anymore. So that's our domain. And the list of features that Jimmy has to provide. All right, so let's take the first one, calculate final checkout. So the idea is to execute evaluate value for the order, the final value for the order. So the first thing that Jimmy will do is he will basically take that domain objects that we saw just a moment ago and create classes for them. So we have a trade order with all the instances, general order, canceled order, and complex order, and a product, with basic product, discounted product, and out of stock. Pretty simple, pretty much. Now, Jimmy will write first test because he's doing TDD. He's a senior software developer. So he creates a simple test when he has an order with some product, another order with some discounted product, some canceled order. He creates a complex order out of those 3 and expects some result. Of course, the test will fail because there's no implementation for it. Now, Jimmy thinks how I can actually accomplish, how this test can pass. Well, you have to know one thing about Jimmy. He's now senior software developer, but he used to be a junior one. And when he was a junior developer, there was this one particular book that he was constantly being bitten up, he would wake up 3 a.m. in the morning, just, singular factory object, blah, blah, blah. And it's not really a bad book. The only problem is that because now Jimmy is a senior developer, for every problem, he can think only with solutions that are somewhat, combined with that book. So Jimmy thinks of subtype polymorphism. Just a pretty simple implementation, really. So we had those domain objects. Now we only have to do is provide a trait with a method evaluate. And so just a clarification, whenever you see a code in gray, which means it's not really important for this presentation, but I put it into completeness, so we have the whole example, right? But this is not really the most important part of this presentation. But you guys basically see what we have here, right? We still have that order. The only thing is it now extends a trait with a method evaluate, and every order has to implement that method, right? So evaluate for cancelled order will be 0, for complex order will be fold left over other orders, and general order will be just taking the price and folding over those prices in the products. And the same goes with a product. So we also extend that trait, also provide implementation for this method, and it all works pretty neat. The tests are green. Everybody is happy. And Jim is also happy, probably seeing a light in the darkness. So all right, the first feature is done. Now the second one. So he has to calculate the average of the order price. So the idea is simple. You have an order, you have another order, and yet another one. You create a list out of those 3, then you run an average, and you expect some result. Of course, this test fails, and now we have to provide implementation. Now remember, the Stack Overflow doesn't work. You have to remember how calculate the mean value, how to calculate average. So just in case, Jimmy creates this library, and basically, after digging his old math books, he came out of this, which is pretty neat. And his implementation will basically, he will take the list of orders, evaluate them, and having the values will just run that library. All should be working just fine, but the moment before Jimmy commits, his friend Jack comes by, and he heard that Jim is actually doing this library. And Jack actually needs that library as well. Well, he's just saying, oh, this is really awesome, you're doing this library, but could you also implement it for doubles and ints? Thanks. All right, so now Jimmy is good because that library doesn't also have to work for big decimals, but also for integers and other numbers. The only problem is that such thing as a number, a trait that every integer, long, or big decimal could be inheriting from, doesn't exist. This will not compile. So Jimmy's screwed a little bit, but then again, there's his book he likes and loves, and he finds a solution which basically is called adapter pattern. So Jimmy thinks of an idea that he will create a trait with all the methods that he needs that represent in a number for current calculations. And he will have an implementation for that big decimal and for integer and for double as well. So basically wrap the values, provide implementation. And now he can easily, instead of having a sequence of big decimals, he will just have a sequence of parameterized numbers. And those numbers, they know how to divide and sum themselves up and all that stuff. So the only thing is this thing right now will not compile. So because we now cannot no longer use big decimals, we have to wrap our big decimal into the big decimal number. And because our function is actually returning a big decimal, we have to unwrap the result one more time. So we see that though the solution is working, now it's a little bit going towards, a little bit crappy code, because we see that boilerplate that is happening all around. And we know that this is not the way to go, especially because the calculations are pretty simple. You can imagine how more complex math could look with those adapters. But tests are passing. Jimmy's supposed to be happy, but he isn't, because he knows where that is going towards. But anyway, the feature is completed. And now we had another feature, present current state of orders in JSON. All right, so this is our test. So we have some orders and some complex order built on top of those orders. We want to serialize them into JSON, and we expect a given result. One more time, we write test first. That test fails. Now we have to provide implementation. So Jimmy is wrapping his head like, how can I do that? He remembers all the converters that he used to do before. Once he was a Java developer, so he thinks of another way to do it. Sorry, before he does it actually, he wants to just implement a simple serializer. But there's Kate. Kate's like, I'm happy you're doing this. I heard you're doing libraries right now for a company, so could you do it for other generic objects as well? Thanks. So now Jimmy has to provide implementation that will take anything and provide a serialized JSON. So he thinks of this converter. So you're gonna have like a JSON serializable, which is gonna be an object that knows how to be serialized, right? So it will have a method to JSON, and that method to JSON will return something which is a JSON value. And we simply then just call it, so we will have an object that will have a method to JSON, and having that method to JSON, will be able to serialize it into final JSON representation. So how we could do that? Well, we had that JSON value and everything that you would normally find in a JSON library. Remember, Stack Overflow isn't working. So now, so I will just show you right now the implementation of how the JSON writer might look like. So the idea of JSON writer is just take that JSON value, whatever that is, right, and change it into final representation, final string. But as I said, it is code in gray. It doesn't really matter. Just for completeness, we have it. Just imagine for a second it works. So now we have the whole thing. If you want to use this library, all you have to do is you have to extend the JSON serializable, provide the method to JSON, and that will give this representation JSON value, which you can later on use to serialize your thing into JSON, right? Pretty obvious. And so the coding continues. So we provide that JSON variable into our order. So, this was our general order with method evaluate. Now we add method to JSON, and same goes with cancel order and complex order. So we're just providing those implementations into the business object that we had in our code. And this continues, and continues. And now the test's passing, and they are green. But now Jimmy is a bit confused, right? Because he sees a problem right now. He used to, at the very beginning on Monday, this project was awesome. Like, he had this domain, and that domain was represented in those case classes and traits. But now it's sort of abused. It's starting to become a little bit coupled at this moment, because why actually we have in a single business object method to JSON. What to JSON has to do with evaluate, right? Now, Jimmy knows that for current department that he's working for, evaluate means one thing, because it actually means calculate the order, how much money has to be paid. But for other department that is actually sending stuff in for clients, evaluate might mean something completely different. So the meaning of this function might change, might be different for it, and probably will be evaluate to, or whatever crazy programmer might think of. So now he sees that this object that used to be pure, just representing the business concept, now is becoming more and more coupled with different things from different layers, from different abstractions like presentation or business. And it's a problem for Jimmy, because even though the code is completed and the tests are passing, he remembers this comic book. I don't know if you guys seen it. So it's a life of software engineer, clean slate, solid foundation. This time I will build the things the right way. Oh my God, I've done it again, haven't I? And Jimmy is scared a bit because he's going that direction. He knows he want to have the dry principle, separation of constants, and epic decoupling, and that's not happening within his code. So, act number 3, Jimmy, before going any further, tries to re-implement stuff, refactor, and think for a better solution. So, act number 3, reinventing the wheel. So now we have he goes, first of all, he will try to fix that adapter pattern that you saw. So you guys remember, we had that trait number and all the implementation for different types, all the wrappers, all the adapters for different types. And if you want to use that, you basically had to provide that wrapping in your business logic. So, but we don't want to have that, in our code. What we want to have is this. We want to work on some, whatever type that we're going to have, because as you guys remember, Jack asked him for this code to be more generic. And we also want to just use, when we are using that API, we just want to use big decimals. This thing will not compile, right? Because A might be anything. We don't know if A has a method plus or division or whatever. So what can we do now? So Jimmy thinks of and has an idea. So what if I don't know anything about A, and I will not know anything about A at the level of the scope of this method, but what if I could provide something, and that something I will just call number, and that something would be parameterized by my A, whatever that A is, int, long, big decimal, whatever, And that number would actually know how to divide, how to sum things up, and all that stuff. So that would just work, right? And we can have that trait with all those methods. It looks pretty much similar as the adapter pattern. The only difference is right now, the only difference that you can see is that the adapter pattern was wrapping one value. So the methods were taking just one argument. Here the trait takes two arguments and provide the value. So it looks similar. So where's the difference? So the difference is here. And now once we have it, well, we could. There's a second parameter list where we have to provide the implementation. I don't know if I skipped it. Sorry. So there's implementation for that trait. So we have that trait, right? And we have an implementation for big decimal, and we have implementation for number. So now, in order for this method, the average method, to work, we would have to provide that instance as a second parameter in the second parameter list. However, since this is implicit, right? Here you guys see this is implicit. We can provide this implicit, this number, big decimal number, into implicit scope, and now our API looks exactly the way how we wanted to have it to be working at the very beginning. So no wrapping around, just using big decimals. From our perspective, from this perspective, this is looking exactly the same as working just with a library that was created for big decimals. The problem might be here. Somebody might say this is really not cool. Like, we used to have just divide and plus. This might look a little bit more obscure. But there's this also another cool feature that we have in Scala, which is called implicit conversion. So we could create a class number ops that would take our a, whatever that a is, as an argument, provide the list of methods that we need, simply delegate the implementation to that number object that knows how to divide and sum and do whatever mathematic operations on that A object, and now having that in our scope, we could use those methods. So whatever A would be, string or integer or whatever, this would be wrapped into this number ops and provide those methods like plus and everything. And now this code looks exactly how we had it at the very beginning, right? But we can use it with any type, might be a big decimal, might be a long as we can provide implementation for that trait. And that's basically it. So the tests are passing as Jimmy is happy. All right, so he's thinking, all right, this worked. Maybe it can work with other stuff that I have in my project. So the second thing was the JSON, as you guys remember. So we had a JSON value, and we have the way to have a trait that everybody has to extend. So we could provide a method to JSON that could be then serialized. Now Jimmy, and we had that method in our business object. So now Jimmy is thinking, all right, so instead of this, could I just create a JSON serializer that could serialize anything? Like this A, this function would be just parameterized by A, so A can be anything, but I don't know how to change A to JSON, right? I don't have that function yet. So maybe one more time, there could be somebody else that would actually know it, right? Somebody else that would provide that functionality. So one more time, we create a trait, just a trait that knows how to go from object A, where A is whatever, and provide that JSON value. And now, yet one more time, we create an instance of that trait. One instance going to be for product, and one instance going to be for order. And one more time, there's a code, the whole code for completeness, but it's basically the same stuff that we've seen before and can be skipped. The idea is just we have objects right now those objects extend that trait and provide functionality for both type product and both type order, and both of those objects are in the implicit scope. So now, if we add this order JSON, so if we had this whole object with both of these implementations into implicit scope, the test will just work fine as well. And now Jimmy's thinking, damn, I can do it all the way back to the very beginning. So I can, one more time go with my evaluation. So right, if you guys remember, we had this evaluate method for both products and orders. So we can yet one more time can create a trade. And that trade will know one thing and one thing only. How to evaluate something of type A to type T. Whatever that A is and whatever that T is. This guy will know it. And we can one more time create implementation, so instances for that trait, that those instances being an implicit scope, and those instances would know, for example here, how to evaluate, so how to change product into big decimal, or how to change order into big decimal. So one more time, we have those guys, we have those implementations over here, and now our average method, it used to run with evaluate, right? We don't have that method evaluate, we just deleted it. But one more time, we can create evaluation ops. So it's going to be implicit conversion from whatever type A to something that has a method evaluate that will just delegate to that trait. So I don't know if you guys see pattern here, but whenever we had a problem, we needed some functionality. How much time do I have? Is it 20 minutes or 10 minutes? 20 minutes? Okay. So whenever we had a problem, we create a trait that knows how to deal with that problem for whatever type, and if we want to have some type, we just provide implementation for it. And it simply works. So now Jimmy's happy, like everything is working, damn. So check this out. The business objects are exactly how they used to be, right? Just a clear domain without any functionality whatsoever. All that functionality is being pushed someplace else. It's in one place, it's in one file, in one class. And here is just basically a structure of a business domain that Jimmy has to, so this is the vocabulary from the language that Jimmy is using every day with talking with his clients. No mixing, consents, no to JSON and evaluate in one place. So the Renaissance. And the Renaissance, now Jimmy knows like, damn, I can do it, every day. So there's a functionality, simplify orders, and the idea is simple. We have an order, a sequence of orders, and we just want to have like a one order, which is, merge all those orders into one. So, the thing that we could do is basically, iterate over those orders with a fold left and, merge them together. So we have to think of what would be the zero argument for the fold left, and that could be cancel order. So whatever is summed up with canceled will be just that thing. And, but we still have to provide this plus, so how we can add two orders together. So instead of providing this method plus to object order, we will one more time create a trait which will be called addable, which takes two values of type A and just sum those two values together into that final value A. So we can provide one more time implementation for our addable trait this time, which is parameterized by order. So now having this in implicit scope, we know how to sum two orders together, even though that method add is not in the order object, right? So now, if we want to use this nice feature here so that it looks like if this method plus is in the order object, all we have to do one more time is create addable ops. Yet again, it's implicit conversion. So whenever you have type A and that type A needs this plus method, just wrap that A over that object and delegate the functionality into the trait. And now this works, right? This is basically the code that we wanted to have. That's it. But Jimmy thinks out, but damn, this is really not what I want to have right now. Now I see the light. To be honest, for me, this thing is still boilerplate. I mean, I know I will be folding left. I always need a zero value, and I always need to add things up. Why do I even have to write the whole damn thing? Wouldn't it be just simple if orders would actually know how to fold, and I would just call fold all them? So he creates yet another trait, which will be addable with zero. So this is exactly the same trait, exactly the same method add will be implemented, But also there's another method provided which is called a zero. So if there's an instance for that trait created, you can create a method fold that will know how to fold anything, how to fold any type, integer, string, user, order, product, whatever, as long as you can provide him the instance of that trait. So if we provide that instance, and this is the implementation for the orders, we can now use it just like this, because orders right now know how to fold. And now Jimmy is just, nirvana, amazed, like, because he now sees his code like Neo, so Matrix. And, he's looking at it and he sees all those places, all those different places that this pattern, because he sees that actually there's a pattern, right? We see different places of our functionality, different places in our logic, but the same thing continues to be just popping out. And he knows at this moment that this is actually can be used in other places. But before he does that, the Google is back and Stack Over is back, and we have the act number 5, which is called enlightenment. So Jimmy is doing what he's supposed to be doing in the university, which is basically a research, and he learns some definitions. And the first definition that he learns is a type class. So whenever you guys saw that trait that could be called JSON with a method to JSON, or a number, or with those different ways how to divide things, whenever you see that, so there's a trait with some method, the thing that you see is actually called a type class. I will give you just a definition in just a second. So type class, what the idea behind type class is basically provide some functionalities. With those some functionalities, sometimes there will come some loss. So it's not only that you provide a method to JSON, or maybe add, as we saw with the addable and addable with 0. It might be that, for example, we say there's a trait with that function add, but there's also a rule behind that add. And I will tell you about the rules in a second. But basically, all what that trait was our type class. And whenever we were providing an instance of that trait, we are actually creating something which is called type class instance. And the feature that Jimmy was using all the time, that he was deleting the subtype polymorphism, right? He was removing method from the business object and putting those methods into those type class instances. That is something that is called ad hoc polymorphism. So nothing discovered, nothing that Jimmy created, just basically rediscovered things that already exist. And those types, the way that, who is here used to be a Java developer? Yeah, not that many. But for me, I was, you were always learning that you have to, provide, you had your object, that object was holding some kind of logic, that logic or state, and that state has to be, protected from the outside world. Here, somebody might argue that this is actually crap, because we are showing the whole structure of our object with case classes and everybody can see it. But just the realization is that those classes, those objects are immutable. So in functional programming, we don't really care that you see what's inside, because we are not really that afraid you actually might change it. The other one might say that, for example, well, wait a minute, now what will happen if there will be, for example, there are some scenarios when I, for example, need to add yet another order, right? So in the previous, the subtype polymorphism, all I had to do was create that order, extend with all the traits, provide the implementation, and that would just work. And now with this ad hoc polymorphism, I just have to skip through all the type classes and provide the implementations for all the different type classes, right? But the thing is, you just always have to remember what will probably change more often in your project. Whether you provide a new functionality to your existing domain, or you will extend your domain. Because if you extend your domain, if you're going to have yet another new type of order or new type of product, yes, it's true, you have to go through all the type classes that you have and provide that, yet another case in whatever functions that you have. But more often, probably what you're going to have is you're going to either add a new functionality, or you're going to change existing functionalities. And with type classes, all those functionalities are just in one single place. in the instance of the type class, right? And now from here we can go to all the scary things that you learn in functional programming. So semigroup is actually something that Jimmy created here, which was addable. That's semigroup. That's it. It's actually not added because, as I said, sometimes type classes they come with a law. So we saw that semigroup had a method add. So there's a law. If you implement an instance for a type class and it's going to be a semigroup and you have that method add, you need to have associativity, which basically means that if you have A plus B plus C, so A plus B plus C should be exactly the same as A, wait a minute, B plus C plus A. Those should be exactly the same. You know, that's the primary school, the things that we learn, associativity in math. So that's only it. A monoid is exactly the addable with 0. So it's a semigroup, yet with one additional method, the 0, that provides the natural element for our computation. And there are functors and applicatives and monads and all the scary words, and you're gonna learn, you're gonna read those tutorials that a monad is a burrito or a spacesuit or something. And monad actually is just a type class, nothing else. It's a type class that provides some methods that has to be implemented if a given type wants to be a monad. And those methods goes with some laws. And that's it. Why we should use a monad is a completely different question. But the definition of a monad is just a type class, nothing else. Same goes with functors and applicatives. Basically, that's all I have. But there are some, this is me, my Twitter, my blog, my GitHub. But before we finish it, we still have, 10 minutes? You guys want to see like some functors, applicatives? Because I don't have slides for it, but I have code if you want. Happy about it? If somebody want to leave, just, leave. The thing is, I might probably drink a little bit too beer before this presentation, so. All right, so, wait a minute. Do you guys see the code? So we're not going to go through every example. So basically what I've been playing around recently is Cat's library and Scala-Z library, how those two live together. So we're going to see some type classes from Cat's library, because I think I wrote a little bit more code with Cats. And, so just how much time do we have? Like 5 minutes? Somebody just yells, stop, we're done, and we'll be done, all right? So there's a simple type class which is called show. And show provides one single method here which extends our type, whatever. So we need to have the instance. So here will be, in those imports, we will have instances for both integers and string. And so the show is a type class with a single method called show, which basically works as a toString. So it knows how to provide a string for integer or from string to string or for whatever type that you have into string. And now you might ask, okay, what for? I already have a toString method in my object, right? It's true, but the difference is that just if I have this foo class over here, so you can see this class over here, and if I forget to provide a toString implementation for it, and at some point I will just call new foo toString, I will not get the nice and comfy string representation of that class. It's going to be some hash string whatever. Now, cool thing with show is that if you just a sec, if you forget to provide the instance for that type class, which I just did, I just commented out the instance of type class show for a class 2, this code here will not compile. So that's the only reason why you should show instead of toString. It basically will fail if you forget to do stuff, which is probably a nice thing to do if you want to have a reliable software. All right, so the other type class that we're going to have also in cat library is called equals. So equals works exactly as the, you can imagine equal sign would work. So it will tell you whether 1 is equal to 2 or 1 is equal to 1. Now you might ask me, what for? Well, the reason is, I hate microphone, sorry. All right. So if I were to compare with just a normal equal size, the comparison between integer and string will be just fine. This is stupid. This is plain stupid, because this is always going to be false. Whatever the argument is going to be, if you compare object from 2 different types and you have a proper equals implementation that goes with the Java specification contract for equals method, this is always going to be a false. There's no sense of actually writing this code. You can, instead of this, you can just write false, and this will be just exactly the same thing. With equals, what you're gonna have is that it's gonna give you a compilation error. It's gonna say, I don't know if you can see it from back there, but there's an error here. The compiler is not happy, saying, listen, I cannot do that for integer and string. I think, I don't know, probably in the Dotty language, we're gonna have this equal working exactly as the equals type class. That's at least what I heard. All right. And last thing, before we run out of time, and as I just said, just scream if we did. It's something called a functor. Now, and we're probably going to end at functors. So, as you guys saw, right till this moment, we were providing type classes to whatever type that we really want, right? So it could be for string, for integer, for whatever. Functor is the first type class that is telling you, okay, you can provide my instance for a type as long as that type is parameterized. So in other words, if you remember, I had that class foo. That class wasn't parameterized by anything. So I wouldn't be able to provide an instance for a functor type class. However, I have, for example, here a type class bus, which is already parameterized, and it fits the criteria. So the functor will work with any type as long as that type is parameterized. Now, the functor is pretty simple. It provides a method which is called a map, all right? And that map takes a function that goes from type A to type B. And what you can do is basically map over some content of your object. So an example would be like an option is a functor with a method map or a list, right? So now the question might be, why functor might be needed? Why should I really use it? Why should I care about such a thing as a map? The thing is called a context. So imagine that I had some method, I called it a send message, but probably not a good name. Whatever, some business method. And originally, you wanted to write that method to work with futures. All right, so it could just, this users would actually be a future of a string. And it would be doing something with it. Maybe returning a future of something else, of a user, of a message, or whatever. But then it works pretty nice on production, but now you see your tests are a little bit flocky, they have to do those alls await and stuff like that. So instead of working with a future, you are working with something more abstract. Take a look at the implementation of the send message. The only thing that we are using was a map function which we have in the future. So instead of having a send message taking a user, a future, so the users would be a future, we would say, okay, you're gonna take something of type F, whatever that type F is, but the thing is that type F is also a functor. So we have the instance for it functor type class. So now we can use the map function on the users, even though at this point we don't really know what users are. It might be anything, right? The only thing that we know is that the users understand map function. And so we do the mapping, so we are just adding into for a string which is one character. And here I'm using that method with a list and an option. But also see you guys that have some class bus for which I create an instance of a functor for a functor. And I can also just send message to bus and the whole thing will just work. And the example that I gave just a moment ago with futures is exactly this. You can have a production code which would instantiate a send message with a future, so it would work asynchronously. But your test could, so you could actually call send message with something which is called ID. So ID is also a functor, but it will not change the content of whatever you are wrapping inside it. So your test might be synchronous, by implementation the production code might be asynchronous. So just to wrap things up, I know my presentation probably ends up like HBO series, you know, at the best part it has to end. Maybe I write some blog posts about it. If any of you guys are interested and you have questions, just let me know on the corridor or whatever. Thank you very much.